Alright, in this video we're going to look at situations where we have expanded or reduced octets. Octet meaning 8, expanded referring to more than 8 valence electrons, and reduced meaning less than 8 valence electrons. So the elements that we have to worry about for the reduced octets are boron and beryllium, and obviously hydrogen. Boron is happy with 6 valence electrons, and beryllium's happy with 4 valence electrons. So those we just kind of have to memorize, unfortunately. So here we've got 1 boron. Boron we said is happy with 6. We have 3 fluorines, and fluorine is happy with 8. I'm just going to erase here. And so we're going to do 3 times 8. So that's going to give us 24 plus 6, or 30. Boron, there's still one of them. It's in group 13, so it has 3 valence electrons. We have 3 fluorines. It's in group 17, so there's 7 valence electrons. So we got 21. 21 plus 3 will give us 24. So 30 minus 24 is going to give us 6. Divide that by 2 is going to give us 3 bonds. So we're going to put our boron and surround it by 3 fluorines. And we're going to connect single bonds to each of those fluorines. Boron, even though it doesn't look happy, it is. It's got 3 valence electrons. I'm sorry, 6 valence electrons, 3 bonds. And now let's go make sure that the fluorines are happy. And away we go. Cool. So that's going to make our boron happy, our fluorines happy. And that's how we do these reduced octets. Now, for an expanded octet, let's take a look at something like ICl4 with a negative charge. On the face, on the surfaces, this might not look like it has an expanded octet until we do our numbers to try to figure out how many electrons we would love to have, or how many that we need to be sharing. So we have 1 times 8 because there's 1 iodine, and there's 8 electrons that iodine would need to be happy. We have 4 chlorines. Chlorine would love to have 8 valence electrons, so this is going to give us a total of 40. Still 1 iodine. Iodine has 7 valence electrons. There's still 4 chlorines. Chlorine has 7. So 4 times 7 is 28, plus 7 will give us 35, and then we can't forget about that negative charge, which means we have to add 1 on there. So that's going to give us 36 valence electrons, and 40 minus 36 will give us 4. Divided by 2, that'll give us 2 bonds. Wait, how does 2 bonds fit 4 chlorines onto an iodine? It doesn't. So that means this must be some sort of rule breaker. So anytime you end up with, and you're sure that you haven't made a math error, anytime you end up with less bonds than are needed to make things happy, we're going to be dealing with expanded octets. So when that's the case, what we would love to have goes out the window, because we're not going to end up with what we'd love to have, some number different, however. What we do know is that there are 36 valence electrons available for sharing. So once we draw our kind of skeletal structure here, we've got our iodine surrounded by 4 chlorines. We're going to connect everything with single bonds, and then we're going to go make everything happy. So that gives us 6 electrons around, in addition to the bond around each chlorine. Let's do a little counting here. Let's figure out how many electrons we have in here. So there's, forgot that bond there. There's 2, 4, 6, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. We need 36 electrons, so we only have 32 represented. So any extras we dump on our central atom here. So our iodine is going to get the 4 more that we need, which means iodine's a rule breaker. Iodine ordinarily would be happy with 8, but in actuality it has 2, 4, 6, 8, 9, 10, 11, 12. Its octet has been expanded. Because this is an ion, we put the whole shebang in brackets and put the charge outside of there, and that's how we do it. So the key here, do our math to figure out the number of bonds, and if we come up with a number that just we would not be able to make this compound with the number of bonds that we should have had, we know that we're just going to ignore what we would want and just deal with the number of valence electrons we actually have. Making everything happy, and then any extra electrons go on our central atom. So the rest of them on this page would be